Next up on our list is the OneShotExecutorService implementation. We're going to walk through that particular subclass. And again, this doesn't directly extend TaskGang. It inherits it indirectly through SearchTaskGangCommon. And you can find the code here. So this particular implementation will do a one-shot search for words and a list of string objects using a fixed size pool of thread objects. So we're using a different kind of executor here. It's all based on the thread pool executor in this case, but it's a fixed size pool, and you can find the code there. So here's what things look like. The executor model is a fixed size thread pool using non-virtual threads. Remember, it makes no sense to have a pool of virtual threads, so we always have regular pool of platform threads or traditional Java threads, as it used to be called. The unit of concurrency is a task for each input string, just like the one we looked at with the one-shot thread per task example we just looked at. And then the results processing model will use a blocking queue that stores the results for immediate concurrent processing. As they complete, we will process them. So here's what the class looks like. You can see it's got a fair number of methods in it. It's going to override a lot of the methods that are defined in the underlying TaskGang super class. And what the constructor does is it creates a new fixed thread pool with some max number of threads, which I have set to be the number of cores that the underlying Java execution environment knows about. So we set the executor to be that number. And then we have this initiate hook method, which we don't use a whole lot, but here we use it to initiate the exit barrier with a countdown latch that's given the number of elements to process in the input. We also have a blocking queue, which is going to be used to store the results. These are search results, as you can see, and it's parameterized because it's a blocking queue. And we use this to store and process the search results concurrently with respect to the input processing. And I'll talk about this thing called process queued results in more detail in a minute, but that's what we use the queue for. The tasks are created to run in the fixed size executor thread pool, which was created in the constructor. And you can see what we do here is we call the make task method that returns a task whose run method calls process input. And then we execute that. And what that does is it essentially enqueues that runnable with the fixed size thread pool. So it doesn't directly run the task. It enqueues the task to be run in the fixed size thread pool by one of the available threads when there is one to do the work. Each input string is processed concurrently and then enqueued for later processing. You can see we have the process input method called search for word, which returns the search result, and we add that to our results queue. We're not going to process it right away. We're just going to go ahead and put it there. And the blocking queue is used to hold the results. And you can see here what it does is when process queued results gets called, and we'll see where that gets called, that's going to go ahead and go through all the results we're expecting, and we're going to take them off the queue. And then we're going to go ahead and get the result and print it. Take may block. If there's nothing on the queue yet, or there's not the thing on the queue at the moment, then take may block. So this could be a blocking call. And then the main thread waits on various exit barriers. And so what it's going to do here is it's going to call process queued results. That's what we just looked at a second ago to get the results. And then once that's finished, it's going to go ahead and see if there's anything left to do. It's going to wait on the exit barrier. And if it's done, then it's going to see if it needs to go to the next cycle. And when it's all done, it's going to call back up to the super classes await task done method, which will eventually decide it's done. And so it'll return from the main thread. By default, advanced task the next cycle returns false. So it means that we're doing one-shot stuff unless we say otherwise. And then the task done method, which is something that's called in the runnable that's returned from make task, is simply going to decrement the exit barrier by 1 when it's done. And so that basically says we're finished. And notice if you look way back much earlier here, when we initialized this, we gave a countdown latch with the input size. So let's say that there were 10 elements in the string, in a list of strings to process. Then the countdown latch would be set to 10. And every time something is finished, it counts down by 1. And when we're finally done, then that other call will return. So let's go ahead and take a look at the source code for OneShotExecutorService.java. So here is OneShotExecutorService.java. You can see again, it extends SearchTaskGangCommon, so it inherits those methods that everybody relies on. It has a countdown latch. It has a blocking queue, which we initialized to linked blocking queue. We could have used array blocking queue as well. And then down here, we get the max threads, which is just the number of cores known to the Java execution environment, the JVM or whatnot. OneShotExecutorService's constructor calls up to the SearchTaskGangCommon superclass to initialize the words to find and the strings to search. And then it goes ahead and it makes a new fixed thread pool with that number of threads, the max threads that we defined up here. Here's the initiate hook method. This is passed in the input size, and we use this to make the countdown latch with the appropriate count. which will then be used to dictate when everything's finished. Initiate task gang, we'll go ahead and call the initiate hook. So we say, hey, initiate yourself, please. And then we create ourselves a worker collection, which is a list of callable objects. This is kind of funky and cool. We go through all the items that we have in our input, and we make tasks for each one to correspond to the element at index I we're going to be processing. We convert that runnable into a callable, and we add it to this worker collection. So we've got a list of callable objects. And then what we do is, assuming that we've got ourselves an executor service, which we do, we go ahead and use the executor service's invoke all method. Invoke all it's kind of a funky method that will go ahead and take the collection of callables passed to it and run them all asynchronously. And then when they're all done, it'll go ahead and return. So it's a kind of an interesting way of doing things, not useful for everything, but here we're going to be doing gang scheduling and gang execution. So we're going to invoke everything in one fell swoop. Here's what process input looks like. You can see it goes through the array of words to find. And for each word, we look it up, calling search for word with the word and the input data. And we get the matches, which come back as search results into the results queue. Our task done method here just decrements the count by 1, which will release the main thread when the count finally drops to 0. And here's what await tasks done does. So it takes a look at the number of input elements we had and also the number of words we were processing. So that gets the total count. And then we're going to call this process queued count method. We'll look at that in a second. And what process queued count does is for each of those iterations, it's going to take an element off the queue, which could block if it's nothing in there. We'll then call get, which is needed because we have a supplier, and then we'll print the results. So we print all the results out in that thread. After we printed all the results, we check to see if the exit barrier has been tripped. If it has, it means we're done. We then check to see if there's another cycle to do. If there's not, we drop out of the loop, and then we call up to the superclass to see if everything is done. And that's basically going to be used to shut down the executor service thread objects. And if we take a look here, you can see it shuts down the executor service and then awaits the termination. So this is a much more fulsome example that illustrates many of the features that are part of the Task Gang framework. Some of the other stuff we've looked at before didn't go quite as far to customize all the different pieces, but this is a more complicated example.